When I was searching a power station, which got quite popular in recent times, especially considering the energy crisis, I wanted something that is not too much big and not too much small. So that's why I started considering 70 my Tera 1000, and in the end I pulled the trigger, did purchase it in the end. It is around 6 months later review. I'm a bit late with that, but I wanted to get familiar with product, what it can and what you can expect from it. So, like the name implies, 70 my Tera 1000 is power station with 1 kilowatt of energy storage, or 1000 watts. It is using a 18650 cells. It is not using a LiPo battery. The thing which was a huge thing for me, and that's why I picked up 70 my Tera 1000, is that it can output 1200 watts continuously, or 2400 watts peak voltage on its 220 volts output. For me, that was the main thing which I wanted, because I'm using a heat pumps for heating and cooling. I'm often having electricity disconnects from the network, so I really needed something to power up my heating or cooling for like 15 minutes, half hour. And 70 my Tera was a product which really was getting into my ideas, considering the price, capacity, and its power output. Let's focus now on some specifications of the device, except the output and capacity. We have a front screen, really nice, really practical. It is a color screen. You have buttons here for various functions, like LED lights, which can be practical, not too bright, but okay. You have option for AC fast charge. Basically, you can fast charge your Tera. I will show that later, or you can turn it off if that is not important thing, and you can preserve the battery cycle capacity by slowly charging them. In various settings like language, etc, etc. You have 8 millimeter input for a car charger, which is bundled. It can accept around 200 watts from 8mm socket and Anderson socket. You can use Tera solar panel. Actually, you can use two of them because they are 110 watts. Below 8mm socket, you have Anderson input for your solar panels. 70 my is having 110 watts solar panel. You can use one or two of them for 220 watts solar power, which is around I think around 200 watts peak, like on the 8mm input from the car. Going further, you have USB-A port, USB-A with quick charging, USB Type-C 18 watts, Type-C 60 watts. You have car cigarette socket. Below that there are two, these are EU standard sockets, because I'm in Europe. And to power on DC or AC, you have buttons. And this is the beauty of this multifunctional screen. You have the fan turned on. I don't know if you can hear it, because I am fast charging Tera right now. It is on 100%. We have DC turned on. Remaining time 99 hours 59 output at the moment, considering the current discharge rate, which is basically 0. Below that there is AC, which you cannot turn on if the Tera is charging from the outlet. But if I turn it off, I can turn on the AC output. So I have DC and AC outputs turned on. output power is 0 watts because there is no load connected. But when you disconnect AC charging of Tera, you can turn on a DC and AC output without any problem. It is showing a 0 watts output because there is no load connected, but what I want to show you now is when the Tera is 100% charged. I want to test how much output capacity it can provide on around 1000 watts load connected continuously. So let's test that out and see how much AC output we can realistically get after all conversions happening inside. Okay, everything is ready. A measuring device is set up. Everything is on 0. We have Tera on 100%. And let's start our load, which is a heater. On the screen we can see a current load with estimate remaining time which Tera can provide with the current battery capacity. So we have a 660 consumption, which is similar with the device here. We see that there is slight difference in reported here and reported here, but that is quite normal. And let's see how much kilowatt watts Tera can provide with current load. Let's get back a bit later and check how things are going out. 31 minutes later, we are at 60%, 54 minutes time remaining, and we have 361 watts spent until now. So let's see how much in total will be. So we have 363. 1 hour and 7 minutes. We are on 16%. 724 watts consumed. Let's see how much left. Okay, I seen it, but I didn't record it. At around 1 hour and 15 minutes, it did shut down and restart. Actually, it just restarted AC output. So I need to turn it on again. "30 minutes left." And it did shut down literally 2 seconds after I stopped recording. Okay, I started recharging Tera from AC power. This is a normal charging speed, which is around 300 watts, 3 hours and 20 minutes to fully charge. But if we turn on the fast charge, we see the input ramps up. It is around 700 watts. To fully charge Tera, you need less than 2 hours, which is quite nice. You can charge your Tera if you have a low-cost tariff like I do. Night hours are really cheap, so it is convenient to charge a device like this during the night. The fan is working non-stop. You probably can hear it. There are a few speeds. I think that this is a lowest speed. The second one is a bit more noisy, but it will probably activate at some point during my review, so you will be able to hear it. A beautiful sunny day, 70 my Tera and 70 my solar panel. Regarding a solar panel, it is really well made. You have these, so you can put the solar panel on proper angle. Here we have this back part where you can hide the cables when you are not using it. Also you have a USB-A with quick charging 3.0 and USB-C with 5 volts 3 amps output. Really nice if you want to directly charge your device with just the panel. So quite a practical. We have Tera on 4%. Now is 2 o'clock. So let's plug in the solar panel and let's see how everything works. Okay, the solar panel is on its place. Let's plug in the Anderson plug. And here it is. It started to ramp up. 105 watts, 11 hours and 53 minutes to fully charge. That's a bit unrealistic because the conditions may change during the day, but at the moment it is 2 p.m. and let's see how much charge we will get until around 6 p.m. so in 4 hours. So currently we have 103-4 watts going inside the battery, which is 11 hours and 52 minutes. The great thing, as I mentioned, the Tera is supporting a pass-through, so basically you can turn a DC on and AC on, and you get a multifunctional display where you can see DC output, which is 0 at the moment. You have how much is going inside the battery, which is around 100 watts, and you have AC parameters which are showing, as you can see here, outputs which are currently 0. I will turn on DC and AC because I want to get a maximal input charge without discharge from DC and IC modulations turned on. The great thing about the solar panel is that it can be easily folded like this. In just few moves you can have it in your hand, ready to be transported in a different place. Quite a practical. It is 4 p.m. and one solar panel in 2 hours charged for around 21%. But as you can see, we are charging now for around 175 watts. I achieved that with parallel connection of 2 solar panels. The first one is, as you know, 70 Tera, 110 watts peak. And I have this solar panel which is also designed for around 130 watts. 70 Tera documentation is stating that you need to beware to not go beyond 27 volts input. And this is quite important because you can burn a solar charger for this power station, and you don't want to do that. So by measuring here, you can see that we have 21 volts and we are on the safe side. So Tera is designed for up to 200 watts, which is 200 watts input. Basically we are on safe side. You shouldn't go beyond 26 volts to be on the safe side, and by doing that you are protecting your Tera power station on the long term. And by doing this with 2 solar panels, you're basically doubling your input power and charging speed. So let's see. Now is 4:15 p.m. Let's see in the 2 hours how much input we will get. I really wanted to double check, and you have here the charging with solar panel. The open circuit voltage of the solar panel should be between 12 and 27 volts. So when the peak sun is, and your parallel connection should not exceed 27 volts by any means. Okay, it is 6:35 p.m. It is end for today. Cloudy weather. Tera is getting, even on this really bad weather, 9 watts. So 37% in total, but keep in mind that the weather wasn't really good at all. Like 1 hour later, after I stopped recording, I got clouds here. So quite low input for now, but keep in mind that I'm still getting 9 watts, which is something, and if I had just one solar panel connected, it wouldn't had anything. This test idea was to show you that you can combine different type of panels. There are some rules which you need to follow, so it is not really that plug and play simple. We are in workshop now, 70 my Tera with me. This is my father's workshop. He's not with us anymore. So now this is my workshop. I'm really sad to say that, because I would really love for him to be here and see the device like this in workshop, which is a really good thing to have. Anyway, 70 my Tera have 1200 watts continuous output max. The peak power can be double of that for just a fraction of like few seconds max. This is good for devices which have high power consumption startup like motors and so on. We have here a Makita angle grinder. It is a 720 watts motor. The Tera can handle it with ease. What I want to show you is that there is a huge difference what is on the declaration on the devices and what you get in the real life. So let's power it on. You can see on the screen power consumption. So 720 watts motor in this angle grinder. So let's start it up and see how much consumption we will get. So around 300 watts we get on initial startup, and it even go a bit lower. That is because the engine is working on idle. What I want to show you now, how it looks when we get even more powerful drill and try to cut something and do something more intensive, so you can check out how much a Tera can handle, and you will realize how nice it is to have device like this around the house. I repeat that often, but it is really practical, because some of my devices which aren't really cordless became cordless with Tera, because I can just plug it in whenever I am and use them. You just need to take care of a maximal power consumption of your device. This is a bigger angle grinder. It is 1200 watts, so basically it maxes out Tera output capacity. So let's test it out with cutting disc and see how it goes. You will be able to see this here power consumption in watts. (860 watts on idle). As far as seen, I did check the video, the consumption at its peak was more than 1600 watts, and Tera was keeping without any problem. I didn't felt that grinder was losing power. So this is really extreme situation, but the Tera is working really well, and that is really important with inverters and these portable power stations. You want them to have a good peak power, and that is quite an important factor for these power stations. For them to be able to provide a peak power at short period of time for device to continue working, even if that is not their continuous power consumption. Anyway, this is a pure pass for the 70 my Tera. I prepared a washer dryer with some clothes. Everything is ready. Let's turn on the Tera. I charged it on 100%. Let's turn AC inverter, plugged in washer dryer. So let's do one quick program. Let's see how everything behaves. Let's do daily quick, 1400 RPMs, 30 degree. After this finish, we're gonna do a drying cycle with Tera 1000. The power consumption is really low because this washer dryer is having inverter motor. We see around 40-80 watts consumption, which is really nothing. Because we choose a 30 degree temperature, the heater element started working and it is drawing around 1250 watts. And Tera is handling it without any problem. The fast spin is drawing around 100 watts, which is again nothing special. It managed to jump to around 200 watts at its peak, but again that is just for a short period of time. It is 3 minutes left and it is doing a final 1400 spin. It is drawing, you've seen it peak around 500 watts. Here it is, 600. Yep, 650. And I think that's it. And it is done. 9% spent, 91% left. Okay, let's do now a drying cycle. We're gonna do synthetics because there is a lot of synthetics inside. Drying set to max for synthetic. A low heat because I don't want my clothes to shrink. Let's go. The drying cycle in this washer dryer is based on the sensor which detects the moisture level in the clothes, so the time will definitely change to less. Let's follow up consumption, which should be handled without any problem. As I said, the heater is on. The consumption is 1250 watts. The heater will turn off and on during the drying process, and we have 1 hour 58 minutes left. It will be definitely shorter. It usually gets around 1 hour to completely dry it, but as the heater will go off, this is not correct remaining time number. We are at 42% left. The consumption is 50 watts. It is because the heater is off, and here it is 10 minutes left. It just dropped down this moment while I was speaking, and that is what I was talking about. Basically the program is over, the correct dryness is achieved inside the drum. Let's wait it to finish completely and see how much the battery left we will have. And it is done with 41% left in the Tera 1000. Now it is just cooling down, and that's basically it. It has been around 1 year since I got Tera, and I was using it in various different scenarios, and it never let me down. The majority of times when I was using it was during the winter time when we got power grid shut. It is a huge problem in my village house, and during that time I'm using Tera to power my heating pump. You've seen those example videos, and it really helps to buffer those half hours, 30 minutes for the heat pump to continue heating. Overall, it is a highly versatile device because I mainly shown you AC part of it. DC part is also capable with a huge variety of outputs. You have even type C with 60 watts, type C with 18 watts. barrel adapters with 13.6 watts to in every scenario you can get input and output for everything you need. You can even make an expansion battery, and because it has a pass-through, so it can help expand battery life to some degree. This is not my final video regarding Tera. I plan to follow up with different kind of videos because if you don't have power station, you probably think that you don't need it, but in real world you really need to have something this compact with this kind of power. The inverter inside is really capable. You've seen that it can provide up to 1400 watts continuously, even if it's not rated for that much, but it can, which is the great thing. The problem a bit is that there is just 1 kilowatt battery inside, but this device is not designed to be a long-term solution. It is more a buffer device, so you can use it for demanding devices when it is needed, or less demanding devices for prolonged period of time. I hope you enjoyed watching. Consider subscribing. I'm doing a lot of Powerwall projects in the future, so if you're interested in those things, subscribe, and until next time, see ya.